So what is a limit? So in this video, we're going to talk about what exactly is a limit and what it can be used for. So to better understand this concept, let's take a look at an example. So let's say we are given the function f of x equals x squared minus 1 divided by x minus 1. So what is f of 1? So basically, I'm just plugging in 1 for x. So that would be 1 squared minus 1 divided by 1 minus 1. But we have a problem with this. We get 0 divided by 0, which gives us an undefined value. However, taking a look at the graph, we do see a hole, which represents an undefined value. But we see that there's a point 1 comma 2. So does f of 1 equal 2? Well, no, it's still undefined. However, as we get closer and closer to 1, the values get closer and closer to 2. So let's take a closer look to see what's going on. So let's say I choose an x value that's pretty close to 1, such as 0.9. So when I plug this into the function, I get 1.9. Now let's see what happens if I take a value that's even closer to 1, such as 0.95. Well, then I get a value of f of x that's 1.95. Even closer to 1, such as 0.99, I get that f of x is equal to 1.99. But when I evaluate the function at 1, my calculator repeats the undefined value. So let me just choose values that are still close to 1, but are a little over 1. So like 1.1. Okay, so that's 2.1. What about 1.01? Okay, so that's 2.01. What about even closer, like 1.001? Well, I get 2.001. So what's happening as I get closer and closer to 1, my values are approaching 2. Now, f of 1 is not 2, as we can see. Our calculator is still yielding that undefined value. However, the limit as x approaches 1 is 2. And mathematically, we represent this, we say lim, then x arrow 1 of the function, which is x squared minus 1 divided by x minus 1 equals 2. And so that limit is basically as we're getting closer and closer and closer to 1, but I'm not actually evaluating the function at a value of 1. So now let's take a look at the formal definition of the limit. So the limit describes the y values as x gets closer and closer to a specific value. It's not the same thing as just plugging x into the function, as we saw in this previous example. Now in future videos, we'll learn the difference between right versus left limits, and we'll learn techniques about algebraic manipulation in order to solve limits. Thank you, and I hope that was helpful.